Lesson 310, Dividing Fractions. So, thus far into Unit 3, our focus has clearly been on multiplying fractions. And here's what I'm going to tell you about dividing fractions. If you know how to multiply fractions, dividing fractions is very, very, very similar. Just one little twist that I'm going to show to you. First, when you look at these practice problems, at a quick glance, you'll see there are some whole numbers in there. There are some fractions in there. You got a variety of both that we're dealing with. For our purposes here, when you see a whole number, I want you to rewrite it as a fraction, as itself over 1. In other words, for this first sample problem, whole number 7, let's rewrite that as 7 over 1. Divided by whole number 9, let's rewrite that as 9 over 1. And then here's the trick. We keep what's on the left-hand side of the division expression the same. We change the symbol from division to multiplying, and we flip what's on the right. So keep what's on the left the same. 7 over 1 stays 7 over 1. Change the symbol from division to multiplying and flip what's on the right. 9 over 1 becomes 1 over 9. Now, you know what to do at this point. Check and see if there is cross-canceling. There's not. Multiply across the top, 7 times 1 is 7. Multiply across the bottom, 1 times 9 is 9. We get 7 ninths. And let's go over across here to number 2. 3 divided by a half. Again, when you see the whole numbers, let's rewrite the whole number as itself over 1. Divided by a half. Then keep what's on the left of the symbol the same. Change the symbol from division to multiplication. And flip what's on the right. 1 over 2 becomes 2 over 1. Check and see if there's cross-canceling. In this case, there is not. And then continue. 3 times 2 is 6. 1 times 1 is 1. Final answer of 6. Now, in this case, it's actually possible for us to show a visual model here. Let's say that we've got this model to represent 3 whole. And now we're dividing the 3 whole by a half. In other words, how many halves go into 3 whole? Well, 1, 2, 3, 4, 5, 6. 3 divided into halves, we get 6 of them. 6 halves make 3 whole. 45 divided by 20. Keep what's on the left the same, but let's write it as itself over 1. Flip the symbol. Division symbol becomes a multiplication symbol, and flip what's on the right. 20 over 1 becomes 1 over 20. Check for cross-canceling. Do you see an opportunity to use cross-canceling? Well, if you notice that 45 and 20 both share a greatest common factor of 5, you'd be right. So 5 goes into 45 9 times. 5 goes into 20 4 times. Multiply that out. 9 times 1 up top is 9. 1 times 4 down low is 4. 9/4 is improper. Let's rewrite that or convert that to a mixed number. 4 goes into 9 2 times, and the leftover amount is 1/4. 2 and 1/4. Number 4. Keep what's on the left the same, but we will rewrite the whole number as itself over 1. Change the symbol from division to multiplication. Flip what's on the right. 1 over 6 gets rewritten as 6 over 1. No cross-canceling here. 11 times 6 across the top is 66. 1 times 1 down low is 1. 66. Keep what's on the left the same. 2 or 2 over 1 stays unchanged. Change the symbol from division to multiplication. Flip what's on the right. 5 over 1 gets rewritten as 1 over 5. And multiply that out. 2/5. Keep what's on the left the same. Whole number 4 gets shown as 4 over 1. Change the symbol. Division symbol becomes a multiplication symbol. Flip what's on the right. 1 over 20 becomes 20 over 1. No cross canceling, so multiply that out. 4 times 20 is 80. And that is our final answer. So we've gone through half of these, and hopefully the pattern is becoming clear. If you have a whole number, whether it's on the right of the symbol or the left of the symbol, I want you to rewrite it as itself over 1, like we have done here. Whole number 7 we showed as 7 over 1, divided by whole number 9, which we showed as 9 over 1. Then, once you have rewritten any whole numbers as itself over 1, you're going to keep what's on the left-hand side the same, change the symbol, the division symbol becomes a multiplication symbol, and you're going to reverse or flip what's on the right. In this case, 9 over 1 got flipped to 1 over 9. Check to see if there is an opportunity to do cross-canceling. If so, you can do that. If not, simply finish the multiplication and check that your answer is in simplest form. Let's pick up where we left off. 12 divided by 1/3. There's a whole number. Whole number 12, I'm going to rewrite that as itself over 1. And I'll actually write this all the way out here. 12 divided by 1/3 is the same as 12 over 1 divided by 1/3. Now I'm going to keep what's on the left the same. I'm going to change the symbol, and I'm going to flip what's on the right. 1 over 3 becomes 3 over 1. And 12 times 3 is going to get me 36. 1 divided by 50. I've got two whole numbers here, so let me rewrite them as follows. 1 over 1 divided by 50 over 1. I'm going to keep what's on the left the same. I'm going to change the symbol, and I'm going to flip what's on the right. 1 times 1 is 1. 1 times 50 is 50. 1/50th final answer. 1/6 divided by 7. I'm going to keep what's on the left the same. I'm going to change my symbol. Division symbol becomes a multiplication symbol. And I'm going to flip what's on the right. So 7 over 1 would become 1 over 7. Multiply that out. 1 times 1 across the top is 1. 6 times 7 across the bottom is 42. Number 10. 1/3 divided by 6. I'm going to write this out all the way. First, I will show the whole number as a fraction. 1/3 divided by 6 over 1. I'm going to keep what's on the left the same. 1/3 stays 1/3. I'm going to change the symbol. Division becomes multiplication. And I'm going to flip what's on the right. That equals 1 over 18. 1/9 divided by 4. I'm going to show the whole number as itself over 1. Now I'm going to keep what's on the left the same, change the symbol, flip what's on the right. Final answer of 1 over 36. 1/5 divided by 10. Keep what's on the left the same, change my symbol, flip what's on the right. 1 over 50th. And there you have it. You have learned how to divide fractions, which is a lot like multiplying fractions, isn't it? As long as you know that one little twist.